On to QA we go.
6. Dismissed.
Well, okay, put that back in. Now, the key here seems to be the second dip is always better than the first one, so do the second dip first. Oh, a little modification here, okay. Except that modification didn't work too good. You left a hole. Can't sell holes. Oh, got to be sure of that count. I'm glad I have my ethical QA department here. Except you weren't dismissed. Hold on.
16. Dismissed.
Oh, 16. You see what happened when you change side? Okay, up, forward. I kept my best workers and... Yeah, we're just trying to record here. I got to make these beads and get them out the door. Just put them down there. Now, you're not dismissed yet. We're slipping here. 13. Well, please total up the number of beads for the day. 29, 38, 42, something like that. Come on. 57. Are you serious? 57?
You got me on the wrong way.
57.
Roster, you got me down.
It doesn't matter. 57. I don't, because we kept our best workers, and I had my worst day yet, so nothing more from you. Mr. President, we completed our 4th day of work with our best workers, and we had 57 red beads, our worst day to date.
Well, all I can say is that the management team is stunned and disappointed. This is certainly not what we thought would happen, keeping our best above average workers. We have bet the company on this contract, and so because it has been canceled because of our poor performance, I'll ask you to please dismiss the remaining workers as well as the QA team, the recorder, and so on. We're closed for business.
Here's your severance pay. And your severance pay. And please give our workforce a round of applause. Well, that was the red bead experiment. Now, this was a tool that Dr. Deming used during his 4-day seminars, and we're using it here to demonstrate some ISMS principles, and we're going to critique what just happened. By the way, I'm Steve Prevett. I'm from Floor Hanford ES&H, and the president is Steve Byers, representing the American Society for Quality. Well, first step here is we used a lot of feedback here. ISMS sure includes a lot of feedback, but maybe we could do something different here and plot some dots. If I can, we're just going to put a little graph up. If I can ask the president to help by reading off some points as we go, let us go forth.
You ready?
Yep, ready.
8.
8.
10.
10. 10.
9.
9. Now, I came here to work early on with tank farms, and they were wrapping one fiscal year after the other, only producing the first fiscal year data. And they put a nice curve function through on Harvard Graphics and fit a curve like this and said, notice the fine improving trend to 0. We won't do that, of course. Okay, what was willing worker number 5?
11.
11.
8.
8.
Second day.
What happened to that dip down to 0? Oh well. Second day.
10.
10.
7.
7.
13.
13.
7.
7.
10 and 9.
10 and 9. Boy, it's just bouncing all over the place, isn't it?
7.
7.
11.
11.
7.
7.
4.
Oh, 4.
11 and 9.
11 and 9. And the last day with our best workers.
16.
16.
13.
13.
9.
9.
4.
4. Well, look at that. Linear regression right on down. 4. Okay, what was after 4?
9 and
9
6.
and 6. Boy, this is all over the place, isn't it? And of course, if we're going to produce this as a chart, we'd probably put bars under it and 3 dimensions and colors and the whole works, and there's our performance chart, right? What does it mean? Well, let's offer something here. We're going to make what is called a control chart, which is Hanford Procedure 4294. When you work performance indicators and when you work ISMS, we use these control charts. Now, the first thing you got to do is determine what was the average. And we total up all the days, 56 and 56 and 49 and 50. I'm going to do this without a calculator even. Everybody thinks control charts are hard to do. I'm doing this without a calculator, without a computer. 21, 28, 2, 7, 12, 16, 21, 208, 21, 218 total red beads for 24 people pulled the red beads, and that gives me 9, 18, 36. Looks like the average is 9. So we draw a line across the screen at 9. An amazing thing occurs, does it not? Half the data is above the average and half the data is below the average. That's amazing, isn't it? Yet, how many people are grading our facilities as above average, below average? How many people's children get graded as above average or below average at school? We do performance appraisals. Who's above average, who's below average? We're fating 50% of the population to be below average. And it's always going to happen, right? Doesn't say anything, but we do it. Well, what we do that should be better is the next thing I got to do is express the spread of this data, which is to put 3 standard deviation control limits on the line. Now, in this case, this is a Poisson distribution because I'm counting defects. This works well when you're counting defects. The standard deviation is the square root of the average. Square root of 9 is 3, nice round number. 3 times 3, 3 standard deviations is 9 again. So the upper control limit is 18, and the lower control limit is 0. UCL, average, LCL. There we have a control chart. No computer, no calculators, just a control chart. Now we interpret this. What is happening is I actually have an extremely predictable process. You know, we couldn't understand why every worker was changing from day to day, from shift to shift, but I really have a predictable process. I average 9, I get no more than 18, I get no less than 1, because 0 is on the lower control limit. So anywhere from 1 to 17 red beads is what I get, and that's what we got. We have no 7 in a row above average or any other rules for a control chart, so I have a stable process. A stable process. Yet what was I doing? What was the effect of having the $30 on the table? Nothing. Do we have bonus pay here? What's its effect? What was the effect of doing performance appraisals? Do we do performance appraisals? Interesting. What was the effect of the procedure? Controlled system. Yeah, controlled results, but very widely, it certainly did not meet the customer's demands, did it? How about this numerical goal? 3. Weren't you finally motivated when you had this number 3 out there? Yet, in the MYPPs are numerical targets for OSHA recordable case rates. What good does a numerical target do? Interesting. So what can we do different? Well, let's take this in an ISMS context.